Hey, and welcome back to another episode of This Week with Cheek. I am vipered up and masked up. You know, I love these Corona masks. It not only protects me and you, it also can cover my bald head. So this is an exciting day, a perfect day to talk to you about perfect squares. So let's dive right into it. I'm going to lower my mask so you can see my mouth move just a little bit. So numbers which can be arranged in a square shape. There are lots of numbers. We specifically are going to be looking at numbers that can be arranged to create a square, a perfect square, and then other numbers that cannot be arranged to make a perfect square. So numbers that can be, examples, 1, 4, 9, 16. Those are all great examples of numbers that can be arranged to form a larger square. An example of a number that cannot be arranged to create a larger square would be 8. And what I've done here is I've got several sticky notes, square sticky notes. I'm going to use them to show you what I mean. So I'm just going to start dragging these and make a larger square. So there's 3. And maybe I can, it might not be perfect because it's hard to line it all up exactly even, but I think you'll be able to understand what I'm doing. So you can see I've got 8 squares and it did not create a perfect square. I would actually need a 9th square, which we talked about earlier, to complete that larger square. So we've been looking, or we looked in class today, and something that we've got to do is we've got to memorize the first 25 perfect squares. So you can see right here, this is a list of the first 25 perfect squares. I don't know if I can lift that up right there. And we're going to be working on memorizing these perfect squares. But we also learned today how to approximate the square root of a non-perfect square. So if it's a perfect square root, then the square root of the number will be a whole number. For example, the square root of 49 is 7. 7's a whole number. The square root of 196 is 14. 14 is a whole number. But there's a lot of square roots in between the perfect square roots that are not perfect squares. Okay, their square root is a decimal, a non-terminating, non-repeating decimal, and we're going to look at how to approximate those square roots to the nearest tenth. So here's a great example. This is the example we did in class today. So if you're learning virtually today, this is exactly what we did in class. So we're going to look at the square root of 12. Now, the first thing that we need to do is identify the perfect square root that comes before and the square root that comes, the perfect square root that comes afterwards. So we can look at this list on the left, and the square root of 12 is going to fall between the square root of 9 and the square root of 16. So I'm going to go ahead and write that down. Now the square root of 9 is 3, and the square root of 16 is 4. So this tells us the square root of 12 falls between these two consecutive whole numbers, 3 and 4. Now we can be more accurate, more exact, and determine to the nearest tenth what the square root of 12 might be. We'll use these squigglies here, right, piece of bacon, that stand for approximately, okay? So the square root of 12 is approximately. To determine this, we really need to know where it is on the number line. So I'm going to go ahead and mark this out since it's our first example. Again, 3 would represent the square root of 9. 4 would represent the square root of 16. But in between those two perfect square roots, we've got a bunch of non-perfect square roots. We've got the square root of 10. We've got the square root of 11. There's 12. 13. We've got 14. And 15. And so this really helps us see what's going on the number line. Okay, now I was not able to space them out exactly perfect. Okay, everything really could shift over a little bit to the right. But for our example, I think this is going to work. Okay, as we look at this, we can see we've got 2 square roots between 9 and 12 on the left-hand side, and then when we slide over, we've got 3, 13, 14, and 15. So the square root of 12 is going to be somewhere maybe right around the halfway mark, maybe a little less, and that's where we've got to test some numbers. So I would say this is about maybe 3.4 or 3.5. And the best way for us to determine this, and again, this is without a calculator, is to square these two decimals. So I'm going to multiply 3.4 by itself, and then I'm also going to multiply 3.5 by itself. So we're squaring both numbers. So when we square 3.4, we're going to get 16. I'm going to do the multiplication here. I did notice today students struggling with 2-digit multiplication. We'll probably have to come back and do a lesson on that. So 3.4 squared is 11.56. 3.5 squared, I know what this is because I know a little trick with squaring fives. That's going to give us 12.25. So which one is closer to 12? That's going to be 12.25. It's 25 hundredths away from 12. 11.56 is 44 hundredths away from 12. So we're going to go ahead and say that the square root of 12 is approximately 3.5. Hey, let's go ahead and take a look at another example because I know some of you will probably need that. So let's take a look at an example maybe that's a little bit further. Let's do the square root of 27. So we'll take a look at the square root of 27 now. Same thing, I'm going to identify the square root that comes before and the perfect square root that comes after. And so if I go over here to my chart, I notice that the square root of 27 falls between the square root of 25 and the square root of 36. That tells me that the square root of 27 is between 5 and 6. Those are the two consecutive whole numbers that it falls between. Now again, we want to decide where the square root of 27 is located on the number line. That will help us determine to the nearest tenth approximately what the square root of 27 is. So we've got the halfway mark. That would be 5.5, but I don't think this is anywhere near 5.5. 27 is right after 25. So we've got the square root of 25, then we've got to have the square root of 26, and then 27. So this is fairly close to 5. I would guess that it might be 5.2 or 5.3. So again, to test those two numbers, and this is being done without a calculator, okay? For those of you at home wondering why we're actually multiplying this out, we did not use a calculator when we were doing this. So I'm going to square 5.2, and then I'm going to square 5.3. So 5.2 squared is going to be 27.04. I'm running out of a little bit of room down there. See if I can fit it in. And then when I square 5.3, oh, hold on, caught a mistake. Hey, mistakes happen. That's why you check your work. 3 times 5 is 15. And then 5 times 3 is 15. Carry. That should be a 26. I believe I did the same thing this time. I put 62. Now I think we're on the right track. That's going to give me an 8. So which one is closer? 28.09 or 27.04? So it looks like to me 5.2 is a better approximation of the square root of 27. So that's 2 examples, and we're going to continue to work more examples as we go throughout the week. But hopefully this helps y'all at home who are working virtually, and for those that were in class today, hopefully this gives you a good idea of what we went over if you needed to hear again. Hey, thanks for joining me on this episode of This Week with Cheat.